All right, so we're going to be working on the checking your understanding for topic 8.2, connecting positions, velocity, acceleration using integrals. So we're going to be using a calculator to do these problems. So I will be using this, my online digital calculator tool. This is an emulator of the 84 Plus. This is all the same buttons in the same places, and this is my screen. So that way we don't have to use the camera under it. This works much better. So let's see where we're at. The first thing I'm going to do is type my equation in. I've got 1 plus, and then this 2 times the sine of a fraction. So to get to the fraction, there's two ways that I can get there. One is math, and then the fraction menu. So I'm just going to arrow over till I get there, and number 1. And that's when I will use this time. I'll show you how to do it another way the other time, which is alpha y equals way faster. And so then I have x to the second power over 2, close those parentheses, and there is my equation. So the first thing I want to do when using a calculator is always get it in the calculator screen. The next thing I'm going to do is going back to the problem to read it now that I've typed it in. At time t, at t equals 4 is a particle speeding up or slowing down. In order to find that, I need to know what the velocity at time 4 is. And I need to know the acceleration at time 4. Now, given the strange nature of this test, I don't know how that they're going to do this for you. So yes, we're going to use the calculator and use the calculator to find both of these. However, we are going to show the derivative. So we're going to go and find the acceleration by taking the derivative. This derivative of 1 is 0, with then plus the derivative of this, which is 2 cosine of, so nothing changes, just the derivative of sine is cosine, the 2 just sits there. Then times the derivative of the inside function, which is 2t over t. And then simplifying that up, this becomes just t. So 2t times the cosine of t squared over 2. And so it just took a quick derivative there. Now, I would find these answers by plugging into the originals. Now, both of these are a little bit obnoxious to plug into. I'm going to let my calculator handle that for me, and I'll show you how to do that. But you would plug in by hand the long way. You'd get an answer, but it's really complicated mathematics, and so they would probably expect you to be using a calculator for this. So I'm going to go ahead and use my alpha button, and so by clicking alpha, you'll see that I can pull up alpha trace, brings up all the variables, and so I need y1, so that's number 1. And y1 at 4, just written that way, is the velocity evaluated at 4. So I get this number, which I will record over here as 2.978. Okay. Then, going back to the calculator, I'm going to find the derivative of the velocity at time 4. So I will use my math button, and the derivative is number 8. And so I want the derivative with respect to x of y1, and again, we'll pull up the variables. I'll do it this a different way. Last time I used alpha and trace. This time I'm going to click on the variables button. I need the y variables and number 1 and y1. Again, you'll notice that is quite a bit longer, evaluated at 4. And so I get this number, which I will record over here, negative 1.164. So again, I think they may ask you to show a little bit more work when using the calculator, like, hey, can you take the derivative? Thanks, now go ahead and use your calculator to find it. Again, I don't know. It's the first time this has ever happened. So, what we know, though, is that speeding up or slowing down, since the velocity and acceleration have different signs, the particle is slowing down. And again, I'm letting my calculator kind of handle that. some of the heavy lifting on that problem. But I did demonstrate that I can take that derivative by hand. So if I needed to, I'd be able to demonstrate that for somebody who was watching me do the test visually. Okay, part B. Find all times t in the interval when the particle changes direction. Justify your answer. So the particle will change direction when the velocity is equal to 0, as long as velocity changes signs. So in other words, goes from positive to negative. So let's take a look at the graph. We'll again be using the calculator to help us here. And so I'll look at the graph. Now I've set up my window to go from 0 to 3, and my min and max from -4 to +4, just because it looks like my answers tend to be, not my largest answer here was about 3, my lowest answer was about 2, so I just kind of went around those. And let's see what the graph looks like. Oh, there it is. So it looks like I chose a good window. Again, I went from 0 to 3 because that's what it said in part B. And I chose 4 to -4 to 4 because of the answers I was getting when I was plugging stuff in. So it looks like right here is when it changes, and it does change from positive to negative. To find this exact number, I'm going to go ahead and use the calculate menu here, which is second, and calculate. And so I need to find a 0, number 2. So, and I need to choose something on the left and something on the right. I'm going to go ahead and type now. And so I'm going to say 2's on the left, and on the right was 3. And then my guess is going to be 2.5, as it's in the middle. And there's my answer, 2.707. So, going back to here, I'm going to say at time 2.707 because the velocity changes signs. I'm going to say changes from positive to negative. Okay. Find the position of the particle at time 0. So if I want to find the position of the particle at time 0, that means I need to integrate. And they gave me this particular piece of information, that the position is 2 at time 4. So if I want to find the position at time 0, I'm going to take time 0 is equal to 2 plus the integral from time 4 to the time I'm looking for, 0. So these two pieces came from this piece of information. So my answer is 2 when it's 4. And I'm looking for 0, so 0 goes here, of the velocity dt. So I can leave it like this. There's no need to change it, but I'm going to go ahead and show people that I understand what I'm doing. They have some more knowledge. I am going to let my calculator handle this for me. But 2 minus the integral from 0 to 4 of v of t dt. Just to write it down to show, hey, yeah, I know that it's going to change signs and all those things. We're going to let our answer come out in purple here. We're going to let the calculator find it for us. So going back to my main screen, I'm going to be taking the interval. So 0, actually, let's quit first. 2 plus the integral. Actually, I'm going to go ahead and do minus. Math, and I want 9 FINT from 0 to 4 of y1. So alpha trace number 1 y1 dx. And just to demonstrate that that's the same as if I do the other one, 2 plus from 4 to 0 of y1 dx. And I got the same answer, so that's good. My answer is -3.815. And so going back to record that, I get negative 3.815. That is the position at time 0. Find the total distance the particle has traveled. So it says total distance. That's very, very important. I'm going to take the I'm going to take the integral from 0 to 3 of the absolute value of v of t dt. So again, I'm going to let my calculator do this for me. So we'll jump back over to the calculator. And so I'm going to go ahead and go into the math menu and number 9 and from 0 to 3. And here's where it gets a little tricky. I need to get the absolute value on here. So if I go under math and I go over to the number, right here where it says number, so just arrow over. First one is absolute value, so I'm going to go ahead and use that absolute value of y1, alpha trace, number 1, y1, dt. So there I am. There's my problem. You notice it's taken a lot longer to think. There's my answer, 5.301. And so there is my answer of 5.301. And didn't ask for any justification. That's my answer. So that's the first one. We use the calculator the entire time. It's important to recognize that that's what happened there. And so let's see what we can do. So the next problem, which is a multiple choice question, and again, you won't have any multiple choice, but it's likely that they'll take a problem that would be multiple choice and strip the answers and have you do it anyway. So a particle travels in a straight line with a constant acceleration of 4 meters per second per second. So we know the acceleration, a of t equals 4 meters per second per second. So you can either have 4 meters squared, that's more of a physics way to write that, or per second is how we would write that more in a calculus setting, or you can say meters per second squared. I'm a big fan of second squared. At time t equals 3, v of 3 is 16 meters per second. How far does the particle travel during the time interval when the velocity increases from 4 meters per second to 24 meters per second? So velocity goes from 4 meters per second to 24 meters per second. So what they're asking us to do here is, 1, find the velocity and integrate it from 0 to 4. So we are being asked to integrate from 4 to 24 v of t dt. We have to find it. And so we're going to have to do some integration here. So a of t is 4. That makes v of t 4t plus some constant. Then we're going to use this initial condition to help us find out exactly what it is, what C1 is. So we know that v of 3 equals 16, so that 4 times 3 plus c, and I used 1 just in case I need to do any more. So 16 equals 12 plus c1, so 4 is c1. So that's my velocity. So then I'm going to take the integral from 4 to 24 of the velocity, and my velocity equation is 4t plus 4. Let your calculator do that for you. You're going to get 70 meters per second. This is probably not a calculator active problem. You could integrate by hand, and you would get 2t squared plus 4t evaluated from 4 to 24, which would still lead you to 70. So we will talk later. Have a great day.